And welcome everybody to the Daily Space Weather Show, coming at you once again from the Smash News Network, least busted name in news. I'm your host, Dan, aka Smash-O-Mash, just bringing you the world's most comprehensive daily space weather content, as well as the most detailed solar imagery. We had a massive series of filament eruptions once again. This one took most of the day to subside. It's actually still hanging out down there around the southeastern limb. We also had additional coronal mass ejections. And guess what? There's another one headed in Earth's direction. So, yeah, it's a lot of action. Not to mention the fact that the sunspot number is now up to 232. The radio flux still at 227. So, yeah. Still not expecting it to be solar maximum, though, folks. So it's only April, and we're expecting another approximately 6 months until solar maximum. It's exciting times for space weather. Of course, we started covering space weather just around solar minimum. And check out this sunspot up close. There's this weird, transitional region there where it's kind of dim. And, yeah, it looks like chromospheric heating. And I wouldn't normally say such a thing, but it is 304 angstroms, which does sort of show a bit of the chromosphere. And that looks like chromospheric heating going on there. In between those white areas, you see there's like a solid orange. That is not a super common feature there. So, and the reason I say it looks like chromospheric heating is because I just happened to have coincidentally seen a paper about this. Now, maybe somebody brought that up, shared it on Twitter because they saw this scenario happening here, but it's probably a good time to look at things like potassium and calcium chromosphere lines for that group of sunspots. So yeah, it's been a very interesting sunspot group, and the likelihood of an X-class flare is ultra high. And we'll get to more of those custom images. Here's a that's a 48-hour video actually. The previous videos are all 24-hour videos. That's a 48-hour one. And yeah, ionized iron in 94 angstroms. So showing 2 days of that massive sunspot, which is just barely crossing the 0 degrees solar longitude mark. So just today it's finally crossed into the western portion of the solar disk. And the likelihood of large solar flares, including X-class events, is extremely high. Extremely high. Like 1 out of 3, according to the automated flare monitor. Now, if you've never seen our community post, you should check out our community post. You can find them at youtube.com/smashomash/community. And one of the community posts that we put up today is shared by Eugene the Philosopher. So he shared a link to this. He uploaded this image. I just wanted to show you this because this is a comment that we get all the time about the spooky pole shift. Oh no, the pole shift. We're all going to die because of the pole shift, right? Earth's magnetic field, it's losing strength. Well, look up there in the upper right. There's that massive spooky decrease that we've recently seen. And what I usually say to people is what we're seeing right now doesn't even count as a magnetic excursion in geologic terms. It's not even a blip on the radar, geologically speaking. So it's just ridiculous that anybody's spooked of the pole flip, first of all. And second of all, we did put up 2 new videos in our Ask a Particle Physicist segment. So make sure you go subscribe to Eugene the Philosopher's channel. Maybe become a Patreon of Mr. Bagashov the Philosopher. There are the offerings for the Ask a Particle Physicist segments. And if you'd like to submit a question, well, the instructions are with the videos. So, yeah, feel free. There is a forum specifically about this at smashomash.com/forum. There are all kinds of links that you can visit, so please do. The latest episodes are called Segment 19, Pseudoscience Trash Unpacked, and Segment 20, Heliophysics is the Basis for Cosmology. So a lot of people may not realize that, but anyway. We'll take a brief look at planet Earth. These are the erupting issues. Abico, that's a volcano. It's producing a 15,000-foot ash plume. Same with Ibu. It's at 15,000 feet of altitude, the top of the ash plume. Luotobe also exploding. Also Luotolo, Semeru, Dacono, Fernandina continues to effuse new real estate for Ecuador. Santiaguido exploding, flight level 140. It's a 14,000-foot ash plume. Also Fuego, Nevado de Ruiz, Sangay, Revenador, and Sabancaya. 23,000-foot ash plume over Sabancaya. Please don't pole vault the caldera. As far as earthquakes go, there are the past 90 days, and here are the past 24 hours. So this is what's been shaken for larger earthquakes, a 5.2 at the Fiji Islands. It was at the surface. No apparent fore or aftershocks associated with that, at least not at the moment. 5.7 at the Loyalty Islands to the east of the Fijian quake. Also a 5.2 at the central Mid-Atlantic Ridge, right near the equator. Beyond that, Bupkis. Those are the 5 and greater magnitude quakes. Now, let's head back to this imagery, the house favorite 171 angstroms. Not half bad. Ah, yes, the SDO. It is so good. So good. And for all of the viewers who complain about we don't have enough data and so forth, it's pretty sad that you don't think we have enough data. Do you even understand the data? If you're like mad that we don't have enough data about, I mean, we get this sometimes, we don't know anything about what's going on in space. We know a lot about what's going on in space. So anyway, the 10.7 centimeter radial flux is at 227. I'm not sure if that needs to be updated or not, but it's actually, okay, it's Solon.info showing 227, and so is the Space Weather Enthusiast dashboard. So let's just assume that's correct. 227. Look at the sunspot number there. At Solon.info, sunspot number is shown as 248? 247, something like that. 247 sunspots. That would be a new high for this cycle. And again, like I said, you can expect a year of activity at this level because we're 6 months from solar maximum, so you can expect levels as we see it now to increase for 6 months and then decrease back to these levels. So, yeah. And if you're watching YouTube channels that claim the sun is shutting down, we're in a grand solar minimum, it's, I don't even know what to say. It's just, to say it's pathetic, we need like a new word for pathetic in the English language. So yeah, here's a Space Weather Enthusiast dashboard, and it looks like it's going to be calm here until the 22nd, according to NOAA. So there's NOAA's Enlil spiral, and they don't have any new CME impacts. They haven't modeled today's CMEs, coronal mass ejections, but it looks like European Space Agency has. So they're seeing what I'm seeing, and so agreeing with ESA. So yeah, another CME coming late in the day on the 22nd, early in the day on the 23rd. So yeah, there's that. So for all you Aurora chasers out there, make sure you follow us on x.com/Smashomash. Otherwise, we might not see your auroral shares. You can also message me or tag me in an Instagram post. That also works. Next, Earth's magnetic moment from space, and we have had some space weather. We've had some mild geomagnetic storm conditions, basically as forecasted on the channel. So yeah, multiple CMEs here rolling in over the past couple of days, and no surprise to our regular viewers. It's called doing the work and not being lazy and bad at your job and forecasting space weather. Not that hard. If you don't look, you won't find it. So that was Earth's magnetic moment from space. Here's Earth's magnetic moment from the ground. And again, we're having some geomagnetic stormish conditions right now. So there's what's going on in North America as far as changes to Earth's magnetic field there. So that's Geospace Delta B, changes to Earth's magnetic field as modeled by the Space Weather Modeling Framework. It's the last 4 hours of North America's magnetic moment from the ground. We'll also show the whole planet view. There's the flat Earth. Or maybe it's a cylindrical Earth. You know, if you just wrap that into a cylinder shape, maybe it's a cylinder-shaped planet. Maybe Earth is shaped like a pipe that goes on forever. Of course, everybody that's a regular watcher of our channel is aware that Earth is croissant-shaped. So, I mean, stop believing all the lies from NASA and stuff. I mean, Earth is clearly shaped like the French breakfast pastry, the croissant. I mean, with the poles at the points of the croissant. Everybody knows this. Everything's croissant-shaped. Duh. So here's our geoelectric field map, and we are seeing some induction into the power grid. So yeah, geomagnetic storm conditions. We may see some aurora at mid-latitudes tonight, although things have been weakening in the past couple of hours. So it looks like we're going to stay out of geomagnetic storm conditions when it comes time for North America to be able to see the aurora. So that's some bad timing, but there may be some great auroral shares in places like Eastern Europe and perhaps Asia, like, I don't know, like Siberia and things. May have gotten a great show recently of the aurora. So yeah, KP is still at 5, but it looks like that's going to subside. So a G1 geomagnetic storm condition there. Again, not likely to remain in that sort of a state, and here's why. It has to do with the solar wind. So the magnetic fields have weakened here. We saw pretty strong fields there with a strong negative BZ component. As you see in that top frame there, a field of 15 nanotesla with a BZ of negative 14. That induces quite a bit of current into the system. So even with not that high of a speed or a density at only 8.5 protons per cubic centimeter and under 500 kilometers per second, we did see geomagnetic storm conditions happen, mainly because of that field and its vertical component. So the Discover showing pretty similar data there, but an even higher density. Density making it up to about 12, 13 maybe, about 13. With a similar magnetic field there, 14 nanotesla with a BZ of, there we go, 15 nanotesla with a BZ of negative 14. So that's a pretty strong field. And we are seeing the speed continue here, but the magnetic field is weakening. So speed at now 500 kilometers a second, density about 7.5 protons per cubic centimeter, and the magnetic field is 11 nanotesla at a positive BZ of 4. So we're going to come right out of geomagnetic storm conditions, probably go right down to a KP 2.66. Anyway, here are our GOES magnetometers. And yeah, that's the past 3 days. And as we forecasted, you can see some sawtooth variations there. And in April 19th especially, CMEs have been impacting. They've been minor as we forecasted. So next is our top view ecliptic plane field plot. So good. And Earth is still in a south pole oriented magnetic sector. And that's going to be out of here by tomorrow. Earth will be in a North Pole sector by tomorrow's Daily Space Weather video. There's another forecast for you. Let us know tomorrow if it's accurate. Here is our line of sight field plot. Photosphere magnetism depicted in grayscale. Polar fields in green for north and red for south. Solar B field in blue. Those are the potential field surface source lines. The B field being the field that goes through the magnet, this magnet being the sun. And let's move on to coronal holes. There are the past 4 days of coronal hole activity. And we have North Pole coronal holes rotating in here. No real surprise there with a North Pole magnetic sector to arrive tomorrow. That is what you'd expect. And we are expecting a continued uptick not only in sunspots, but also in coronal holes, because we've seen a shortage of coronal holes thus far throughout solar cycle 25. And you have to pay up. The fields have to migrate. The fields start out north and south. They migrate, and the coronal holes are the location of those migrating fields. So every day throughout solar cycle 25, we've shown the polar field reversal process happening there via those images. And of course, just showing 211 angstroms is also, showing coronal holes. So let's take a look at that, shall we? There's 211 angstroms from SDO. Yeah, so those new coronal holes there rotating into the east, those are North Pole oriented. The sector boundary crossing is on the eastern side of those series of sunspots. And a new sunspot has actually formed behind there as well. So we may even see an additional uptick in sunspot number going into tomorrow. And speaking of sunspots, that's what we're getting to next. So sunspots, it's an exciting time for sunspots because there are a lot of sunspots. And according to the Royal Observatory of Belgium, there are indeed 232. So maybe Solon.info somehow counted those sunspots earlier and they got to 240 something. I don't know, whatever it is. But check it out. Very high likelihood of large solar flares, especially out of sunspot 3638, I think is the one. 3638, this one to the south, right, well, it might be 3643, but there are a bunch of named groups in there. That is just one crazy, rowdy area. And yeah, we'll show you the magnetic fields here, and they are pretty burly. They are burly magnetic fields, folks. Burly magnetic fields, I tell you. So here is there's the SDO continuum. And that trailing sunspot group there, the one farthest to the east, south of the equator, that is a new group. So, yeah, we'll have a sunspot uptick tomorrow, assuming that no other rapid changes happen. Looks like some growth in this northern area as well, right up here. A little bit of growth, a little bit of degradation, a little more growth. Yeah, expecting another mild uptick in sunspot number for the next 24 hours. So here are the magnetic fields. Now let's zoom way into that series of sunspots there. And there are multiple locations there where you have some deltas. Deltas are where you have strong, well-organized magnetic fields right next to each other of opposite polarities. Here we've rotated the field of view so that it's basically stationary. It's a little bit easier to follow the changes happening in magnetic fields there. So there are some areas like over here. So here are some areas where you can expect to see large flares. Well, first of all here, I mean, this is by far the most likely place to see a large flare. But also up here we are seeing some action. Little bit of stuff going on in this area, but especially that first arrow, that one right there, that's by far the most likely place to see a large solar flare. And we've seen a series of massive filament eruptions from that area as well. So here we've zoomed back out to show the continuum once again. That's a 24-hour video, 30 frames per second. SDO continuum, the Solar Dynamics Observatory, observing the photosphere, the layer below the corona and the chromosphere, the photosphere, the surface of the sun, where sunspots occur. Next, flares and energetic particles. And what do you got? Proton flux is flatlined. No proton events. No proton events. As far as flaring, 2 M-class events over the past 24 hours. And we'll take a look at those. How about some 131 plus 94 angstroms together? So those 2 M-class events actually taking place in different sunspot groups. But lots of fireworks going off there. Not too shabby. All right, and before we get to CMEs, how about a solar system forecast? So this is where things are located today, courtesy of theplanetstoday.com. Yeah, theplanetstoday.com. Here's your 1-week forecast for the solar system as Mercury abandons the Earth on this lonely side. Here's where things will be in 1 week. Mercury's catching up to Mars and Saturn and Neptune and Venus. Earth will be left alone once again, with no other planets on this side of the solar system. Next, a star chart. And like I said yesterday, if you're up before dawn, you may see a great view of Saturn and Mars, but right after that, Mercury and Venus, very close to each other there. Actually, Mercury will be higher in the sky than Venus. So that pair visible there before sunrise tomorrow. If you've got clear sky and low horizon and low light pollution, might be able to pick up Mercury, the solar system's fastest planet. Next, our astronomy photo of the day. It's the Carina Nebula. And of course, the star featured here is Eta Carinae. So Eta Carinae is I believe it's the largest star known. It's someplace in this mass in here. And there's also a nebula called the Keyhole Nebula in there to its right, somewhere up in here. I don't know. It's nebula names are very arbitrary, so there you go. apod.nasa.gov if you want to check it out yourself. The Carina Nebula, taken from a ground-based telescope. So lots of views there of a bunch of gas and obscuring dust. Let's move on to CMEs. CMEs. There's another one on the way to Earth, and it's one of these events here from today. I think it's the more recent one there, which means ESA must be updating their web portal, or maybe their thing does it automatically, but that's a pretty fast update there. So props to the European Space Agency. Let's see if we can get a bearing on that. So what do we got? I think it's that one. No, maybe not. So there's one out of the west and then one out of the southeast. Probably the one out of the southeast, containing an earthly component. Well, let's move on and look at stereo A. By the way, that's where it's located. We show that the red dot over there, that's stereo A. It's just recently passed Earth, and now it's speeding away from Earth and gaining distance. And that's a good thing, because the farther away it gets, the better of an angle we get, the higher the capability we'll have to forecast CME velocities and also trajectories to some extent. So here is there's stereo A on the left and the difference imagery on the right. And do we have today's events? You should see one out of the west, and then one out of the southeast. So there's the one out of the southeast. Might be multiple events going on there. I think there are. So I think there could be a far side event happening around the same time here. Keep in mind, folks, it is kind of a common thing to see flares on the far side and the Earth side of the solar disk kind of all at once. All right, so next is our custom CME imagery. Whoops, there we go. There is our custom coronagraph setup. LASCO C2 and C3, as well as the SDO. Yeah, so that filament erupted right out of the center of the solar disk there. Right from this area right in here, you'll see a very dark absorption feature there known as limb darkening. That is when a bunch of plasma, plasma that's not emitting in 304 angstroms obscures the emissions from the surface of the sun. Limb darkening, it's an absorption feature. So here you'll be able to see that a little bit better. Right down here, you see this filament right there. So that filament made its way out. It looks like it's pretty slow moving. I would tend to agree with ESA's forecast there. It arrived late in the day on the 22nd into the 23rd. That sounds accurate to me based on what I'm seeing. And here you'll be able to see that filament eruption a little bit better. We've added the 193 angstroms wavelength there to the SDO imagery. So there's the full zoom. And one last thing, let's take one more look at this insane series of sunspots. That's like 4 named sunspot groups, about to be 5. And yeah, look at that boiling orange colored area there in between those bright white regions. I mean, that is just a bonkers series of sunspots right there. So extremely noteworthy. And yeah, I suspect there's some chromospheric heating there. Now I gotta see what's up with that. I think I might have shared something on Twitter about it, but I definitely saw an article somewhere. So I don't really keep a bibliography of my social media travels, as it is extremely disappointing to be traveling social media. But anyway, let's move on to filaments. Filaments, wherefore art thou, filaments? Because magnetic fields are suspending you and allowing you to defy the sun's massive gravity. Still plenty of filaments on the Earth-facing portion of the disk. Also some prominences there you can see hanging off the edge of the disk. And check out this one that's rotating in here. This one right in here. That is a massive one. It is vertical as well. Perhaps we'll have to name that one the, the Charles Barkley filament. And if you want to name filaments, join us over on x.com/Smashomash. And before we get to bonus features, here are the past couple of hours from the GO 16 SUVi, and another massive CME popping off there. Looks like a very slow speed one. And some of the plasma missed its opportunity to escape the sun's gravity and is on its way back down toward the chromosphere. Anyway, once again, if you don't follow us on X, you might not see the hashtag name that filament stuff. And of course, we are wondering if the smell of all public locations in Colorado is of Bengay and patchouli. Can you let us know in the comments? Does every movie theater in Colorado smell like Bengay and patchouli? Now here's a guy you should follow on Twitter. He's got. Do you know what his background image is? You see those red and blue lines there? You know what that is? They're Fraunhofer lines. Fraunhofer lines. And you can look that up yourself. I'll bet you have access to the internet. So anyway, follow Scott McIntosh. That's a good one. And here's one I just discovered today. The HAO Sun Earth Lab, dating all the way back to 1940 and located in Boulder, where it smells like patchouli and Bengay. Correct me if I'm wrong in the comments. All right, what's up with that? The radio flux dropped to 213 while we were making the video. Okay. Oh no, the sun's shutting down, folks. The radio flux is all the way down to 213. What are we going to do? Oh my God, dear God, the sun is shutting down. Pardon my sarcasm. So we do have some charging hazards here. They are minor. They are over the northern Indian Ocean and Southeast Asia and the Middle East. Here's our electron flux, and it's still kind of low. We can expect to see a big uptick in the coming days. In the next 48 hours, actually, we can expect to see a big uptick in electron flux. So that's going to come up off the floor. That's the past year of the greater than 2 million electron volt electron fluence. Here's the forecast model. And NOAA's expecting a little bit longer time there. I don't know, whatever. I don't disagree or agree. I just don't care. Here's our ionosphere imagery. And you've got, we like to show this because some people aren't aware of the temperature inversions in the atmospheric layers. Like the troposphere is warm at the surface and cold at the top, and the stratosphere is cold at the bottom and warm at the top, and the mesosphere is hot at the bottom and cold at the top. Stuff like that. Or the penetration of electromagnetic radiation. For example, X-rays, they never make it to the stratosphere. They're absorbed by the time they get to the bottom of the mesosphere. Extreme ultraviolet, the reason the SDO and the GO 16 are in space is so they can see the 304 angstroms and the 171 angstroms wavelengths. As you can see, the EUV bands, 10 to 120 nanometers, they never make it to the mesosphere. They're absorbed by the thermosphere. And then, of course, chemical concentrations for that over on the right. Chemical concentrations, the stratosphere, that's where ozone is found and things. Not the pollution ozone, the natural ozone that, allows the stratosphere to behave like a light filter. Anyway, here is our ionosphere map, courtesy of Australian Government Bureau of Meteorology. And we are seeing some low-frequency anomalies in there, as you do when you have geomagnetic storms. So that should be of little surprise to our regular viewers. Here is the anomalygram. That's anomaly in megahertz from a 30-day median. And you'll see quite a bit of red showing up. That is what happens when the ionosphere puffs up, gains density, and vibrates less slowly. It's becoming low vibration, bro. Bro, the whole thing's on a low vibrational level, bro. I've got a fever. I'm operating on a high vibrational level, bro. Please don't say the term energy. If you're talking about a science thing, don't just say energy. If you just say the term energy, it's completely meaningless. You got to have units. Like units. What energy? Energy? Spooky energy from space? Plasma's not magic. And anyway, here's the WAM, the whole atmosphere model of the global ionosphere nowcast. We are seeing some massive electron contents there over the southern hemisphere. Look at the southern Pacific Ocean. They have massive GPS errors. If you're trying to use a GPS, where you see those red blobs in that imagery right there, those red areas. those will feature huge GPS errors. All right, continuing right along here, the latest intensitygram and latest colorized magnetogram. Let's take a look at this beastly sunspot group. Just bonkers. Come on, then. There we go. Look at that. Dag. That thing is burly. And yeah, it's a beta gamma delta class sunspot group. That's period. Now let's go to meteorology. Starting out with the world's ocean temperatures. That's sea surface temperature. And look at how hot the Indian Ocean is, folks. The Indian Ocean is hot. 88.8 degrees. Dear God. Southern Ocean? Well, there's still some ice in it. I don't know. Maybe you were frightened that it was going to melt or that the whole planet was going to freeze. I don't know. Here's the Pacific. Let's don't forget the Atlantic. And what about the Arctic? So let's skip jet streams and winds today. We'll show satellite imagery. We're pretty spaced out on the channel, but we zoom all the way into the lower 48. So you got to wait. We zoom in on the lower 48. There's satellite imagery. Here is mean sea level pressure. And here's our weather.gov map. Weather.gov, some flooding showing up there and some very cold temperatures showing up there. Weather.gov is where to get your warnings if your location is lit. Here's a forecast for you. The GFS 72-hour pressure and precipitation. Pressure and precip. 72-hour GFS total accumulated precip in inches. Texas is going to see some 4-inch rain totals. And last but not least, temperature anomaly. Temperature anomaly in degrees Celsius. Wow, look at all the hot air coming to Colorado. Dear God, western Colorado is going to just be encased in hot air. Is it coming from internally, or is it just the weather? Does it smell like Bengay and patchouli? Let us know in the comments what you think. Next are lightning. There's a lightning scenario. Here's a real-time lightning map, courtesy of lightningmaps.org. We do have some active cells. They are minor thunder showers for North America. If you enjoy the content, press the like button, lest thy soul be cast into an ever-deepening and darkening abyss of doom, destruction, and doo-doo diarrhea content. Help the channel out. Press like, press share, leave a comment. Get mad, get involved. Visit our websites, pick up some merch, tell your friends and foes about us. Get them mad. Get people believing reality. Help people to become pragmatic realists. Yeah, that's what I am. I'm a pragmatic realist. I'm not an idealist. I'm not a half-full, half-empty cup kind of guy. I'm a pragmatic realist. I don't care what's in the cup or the size of the cup or anything of the sort. Here's satellite imagery. And, you know, it's a very good thing to understand people's intentions before you prejudge them. So, you know, if you assume that you know why somebody does a thing, you may want to ask first. So anyway, there's a water vapor map. And it's pretty dry over the U.S. Seems like a good scenario for bicycle racing. Something you ought to try if you're thinking about it. Anyway, here's your recap. Yeah, there's probably a bicycle race within an hour of you somewhere. Try it out. Do a time trial. Here's your satellite imagery. You know, a time trial of you versus the clock. No mass starts. No crazy sprinting. No dangerous Peloton riding. Just you versus the clock. There's the water vapor map to close things out. And this is where I'm closing out. I got to head back to the bunker because I am so spooked of space. Oh my God, so many sunspots. Dear God, pardon the sarcasm. I'll see you next time. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. S-bars, don't fail me now. Whoa!